We will also need to use Newton's second law, which is F equals ma. And you need to remember that A is the same as dv by dt. So if you take your velocity and differentiate it, it is the same as the acceleration. Now, for other questions linking to modelling, you may need to know what happens in the future. Now, this question doesn't rely on this, but other questions where you've got a modelling type of question, if they're talking about something that happens in the future, that means what happens as t tends to infinity. So what happens as t gets really, really big, what will happen to the velocity or whatever function it is as t gets really, really big. And if you're asked for the maximum, that means that you have got to differentiate and put your differential equal to 0. So these last two facts are really key facts when you are looking at modelling. But for this question specifically, the top 3 facts are what we're going to be looking at for this question here. But these bottom 2 points are really, really important when it comes to your exam, because if it's talking about the future or the word maximum is mentioned, these are key things that you need to know. Now I want you to press pause, think about have a go at working out the answer to this question. Now you know the facts that you're going to be using, and see if you can work out an equation for the velocity in terms of time, and press play when you've got an answer. Well done guys, hopefully you've managed to get yourself an answer here for the velocity. So to start with, we need to draw ourselves a diagram, and our diagram is just a very simple diagram where we've got the skydiver here in the middle, we've got a force acting down on the skydiver, and we've got a force acting up. Now the force acting down is the bigger force because the skydiver is moving down and his weight is acting down, or their weight is acting down. And going up, this is our resistance, which is resisting the motion which is going up. So R is equal to 0.8 V. And then the weight of the skydiver is equal to 60 g. So the mass times gravity, where gravity is equal to 9.8, and we're told the mass of the skydiver is equal to 60. Now we've got our diagram drawn, we're going to use Newton's second law here, which is F equals ma. Now my net force is the overall force. Now the force acting down is the weight, which is 60 g. And it's going to be take away the resistance, which is 0.8 V, because the weight, the skydiver will be moving down, so they're coming down this direction here. So the weight has got the bigger value. So we've got 60 G take away the 0.8 V. Or in general terms, my weight minus my resistance is going to equal to 60 times by my acceleration, using F equals ma, where the mass is equal to 60. A is my acceleration, and F is the net force, which is the weight minus the resistance. Replacing the weight with 60 G, replacing the resistance with 0.8 V, and replacing A with dV by dt gives me a differential equation. So we have written a differential equation. So that is the first step of what you've been asked to do, write a differential equation. And in the exam, that will give you 1 mark for getting to this stage here, writing your differential equation and getting it set up. Now from here, we need to integrate this expression in order to find the velocity. Now this expression is dv by dt, but the right-hand side is not in terms of t, it's in terms of v. So we cannot just integrate the left-hand side and the right-hand side and just say that the right-hand side is 60t, because the left-hand side is in terms of v, not in terms of t. So what we need to do is we need to separate the variables. And in order to separate the variables, that means all the t terms go onto the left-hand side and all the other terms go onto the right-hand side. So when I separate the variables, my dt is going to come and multiply up to the left-hand side, and this 60g minus 0.8 is going to divide and come underneath. Now, if you work out the value of 60 times by 9.8, you will get 588. The 60 on the right-hand side has stayed put. The dv is on the right-hand side, that is also stayed put. And you've got the 588 minus 0.8 V on the right-hand side, and you're left with just 1 on the left-hand side, and that's 1 lot of dt. From here, we can now integrate. So the integral of 1 is just t, so that's nice and easy on the left-hand side. This function here is harder to integrate. We could think of 60 as being a constant, and that could come outside the front of the integral sign. So I've got 60 times by 1 over 588 minus 0.8 V. Now, when you've got to integrate 1 over a function, we're going to be using the ln function or log. So I've got ln of 588 minus 0.8v. I've then also got to divide by the differential of 0.8v, or the whole of this denominator, and the whole of the denominator differentiated will just give me minus 0.8. So I'm left with t equals to 60 divided by minus 0.8 ln of the 588 minus 0.8v plus your constant c. Always remember to put your plus c there. Now we're told initially the velocity is 0. So that means when t is equal to 0, v is equal to 0. So that's what that keyword there initially means. So we're going to substitute these values in to work out our value of c. Now if you forget to do this, you will miss the value of c, because not always c is going to be 0 in these cases, as this case it's not 0. So substituting time is equal to 0 and the velocity is equal to 0, I'm left with 0 is equal to minus 75 ln of 588 plus c. So to get rid of the minus term, I'm going to add it to both sides. So c is going to be 75 ln of 588. Once you've got here, we can then substitute that back into this equation here to get a value for t in terms of v and numbers. But our question is to work out the velocity. So we've got to rearrange this equation here that I've got with my new c value on the end to find my velocity. So here is my expression with the c value on the end. So t is equal to minus 75 ln of 588 minus 0.8v plus the value of c, which was 75 ln of 588. Now from here, we need to work out the velocity. So this term here has got the velocity in, so I'm going to take that term to the left and take t to the right. So I'm going to add 75 ln of 588 minus 0.8v to both sides. And at the same time, I'm also going to divide by 75. So the 588 divided by 75, the 75 disappears, so it just becomes 1. And my t that I've taken to the right hand side, so take away t from both sides, is also divided by 75. So I've done 2 steps there, or 3 things at once. I've added 75 ln 588 minus 0.8v. I've subtracted t, and then I've divided everything by 75. So there are 3 things I've done in order to get to this line here. From here, I need to get v on its own, so I need to get rid of this ln, and the opposite to ln is e. So 588 minus 0.8v is e to the ln of 588 minus t over 75. Now the right hand side is 2 functions. Okay, so I've got 2 powers. So rules of indices, a to the power or x to the power of a plus b is the same as x to the power of a times by x to the power of b. So I can separate the right-hand side up into 2 functions using rules of indices. The reason we do this is because I've got an e and ln next to each other, and this e and ln cancel out, leaving me with 588. So the right-hand side becomes much nicer now because I've got 588 here at the front of this function here. Now on top of this, I'm going to rearrange to get 0.8v. Okay, so I'm going to take every 0.8v to the right hand side. This term here on the right hand side is going to come to the left hand side, which is it's now minus 588 e to the minus t over 75. And the 588 stays put on the left hand side. It's just moved to the right hand side. From here, I've now got to get v on its own. So I've got to divide everything by 0.8, and dividing 588 by 0.8 gives me 735. Dividing this 588 by 0.8 gives me 735. So I've now got an expression for my velocity in terms of t. So v is 735 minus 735 e to the minus t over 75. And that will give you all the marks you need to be able to do any question or any exam question. Make sure you tick your work when you've got your answer to show where you're going to get your marks and show that you've got the correct answer. So well done guys, hopefully you've managed to get the answer of V equals 735 minus 735 e to the minus t over 75. If you found this video useful, please share, like and subscribe so we can all get great at maths.